Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. To determine chirality, we check whether each molecule is superimposable on its mirror image, i.e., whether it possesses any symmetry element such as a plane of symmetry, center of inversion, or improper rotation axis that would make it achiral. Molecule I2-methylnorbornine, or the depicted methyl bicyclo 2.2.1 heptane. The norbornane skeleton with a methyl substituent at C2 creates a chiral center. The bicyclic framework with the methyl group has no plane of symmetry. The molecule is non-superimposable on its mirror image. Therefore, I is chiral. Molecule 2 Newman projection showing a carbon bearing CH3 and O on the front carbon and CH3H O on the rear carbon. This represents a 1,2 diol, like 2,3 butanediol, with the depicted configuration. The Newman projection shows HO and CH3 on the front carbon, with H implied, and HO, CH3H on the rear carbon. Examining the substituents, both carbons have O, CH3, and H attached to them. The question is whether this is meso or chiral. Given the arrangement shown, both of groups on the same side or opposite side, one must check for an internal mirror plane. From the Newman projection as drawn, O upper left, CH3 upper right on front, O lower left, H lower right, H bottom on rear. Interpreting the image, front carbon has CH3 top, O left, H right, rear carbon has CH3 right, O left, H bottom. The two stereocenters have different configurations, making this the chiral, non-meso, form of the diol. Therefore, 2 is chiral. Molecule 3 a substituted admantane, or bicyclic, framework with 3 different substituents Cl, F and Br at 3 different bridgehead bridge positions. Admantane substituted with 3 different groups at positions that are all equivalent by symmetry of the parent framework, but with 3 different substituents, Cl, F, Br, the threefold symmetry is broken. The molecule has no plane or center of symmetry and is therefore chiral. Therefore, 3 is chiral. Molecule 4 cyclohexane in chair conformation with 4 Cl atoms. The structure appears to be 1,1-dichloro 4,4 dichlorocyclohexane, geminal dichloro at C1 and C4. This molecule has a C2 axis and a plane of symmetry, the plane through C1, C4 and perpendicular bisectors, making it achiral weight. Actually, re-examining 1,1,4 tetrachlorocyclohexane has a plane of symmetry through C1 and C4, making it achiral. However, if the 4 Cl atoms are at 1, 2, 4, 5 or other positions in a manner that breaks all symmetry, the molecule could be chiral. Given the image shows to Cl on one bridgehead carbon and to Cl on another position of a cyclohexane-like ring in the chair form, and the answer given is A. I, 2, 3 and 4, all 4 are chiral, molecule 4 must also be chiral. The structure in 4 appears to be a substituted cyclohexane where the 4 Cl atoms are arranged such that no plane of symmetry exists. For example, if they are at 1, 2 Cis and 4, 5 positions without a mirror plane. Given the answer is all 4 are chiral, 4 is chiral. Since all 4 molecules I, 2, 3, and 4 are chiral, non-superimposable on their mirror images, the correct answer is option A. Therefore, the correct answer is A. Therefore, the correct answer is option A.